Oh my gosh, my room is so messy and I just cleaned it.
That's because the universe tends towards disorder. It's so much easier to be disorganized than organized. It's called entropy, which is a part of Gibbs free energy.
What's that?
A guy named Josiah Gibbs came up with the Gibbs free energy formula. Gibbs free energy is the amount of free energy available for use. When temperature and pressure are constant, it is dependent on two variables, the change in enthalpy and a change in entropy. Delta S is entropy. Entropy is a measure of disorder, or how many different ways a molecule can be arranged but still have the same energy. Think of it as chaos. Take a glass of water. When water evaporates from this glass, water is changing from liquid to gas, and molecules scatter everywhere. Water has more energy in the gaseous state and is therefore more chaotic, so we say that entropy increases. Entropy decreases when molecules become more orderly. This kind of reaction is unfavorable, meaning energy is required by the reaction in order for it to proceed. Back to your room. Because it got more organized, the entropy is negative. Delta H stands for enthalpy. Enthalpy is a measure of the total energy in a system. When enthalpy is positive, the system is endothermic, meaning heat was absorbed for the reaction to occur. When enthalpy is negative, the system is exothermic and heat was released. You know how you have to put in energy to break a stick? It's like that. You have to put in energy to break a bond so it is endothermic. When a bond is broken, energy is released, and the reaction is exothermic.
Okay, so I get enthalpy and entropy, but what does it mean when you put them together in the Gibbs free energy equation?
A reaction can be enthalpy-driven or entropy-driven, and can also be spontaneous or not spontaneous. If delta G is negative, the reaction is spontaneous and favors the products. If delta G is positive, the reaction is non-spontaneous, meaning you have to add energy to start the reaction. Here the reactants are favored. If delta G is 0, then the reaction is at equilibrium.
Hey, you only talked about enthalpy and entropy when the temperature is constant. What if the temperature is also a variable?
Okay, so let's say that both delta H and delta S are positive values. If temperature is very high, then delta G becomes negative, and the reaction is spontaneous. If only delta H is positive, then the reaction can never be spontaneous. On the other hand, if only delta S is positive, the reaction is spontaneous at all temperatures. If both delta H and delta S are negative, then the reaction is spontaneous only at lower temperatures.
Oh, I get it now!
Okay, let's do a practice problem. Say you have nitrogen gas and hydrogen gas. They react and form ammonia. The delta S for this reaction is negative 198.75 joules per Kelvin, and the delta H is negative 92.22 kilojoules. Do you think this reaction is spontaneous at 25 degrees Celsius?
Well, delta H is negative, so it's favorable, but delta S is also negative, which is unfavorable. We should put them in the Gibbs free energy equation. So delta G is negative. That means the reaction is spontaneous.
Good job! Now don't forget, delta G equals delta H minus T delta S.
And my room is clean! Yay!